cosmic storm. Floating on whimsical wavelengths is the norm. Dancing through the stars, chasing spectrums of light. Riding the waves that are just out of sight.
Welcome back. It's been a minute since we here on Whimsical Wavelengths last traveled through geologic time to look at prehistoric life. Instead of looking at Jurassic Park and theropods like the king of the Mesozoic T-Rex back in Season 1, today we're going to take to the prehistoric skies. Flight has evolved at least 3 separate times over the history of life here on our blue marble called Earth. First, with insects. In the Carboniferous. We actually poked at this back in Season 1 with Dr. Hollister when looking at the respiratory systems of insects. Second to evolve flight is actually the focus of today's topic, with a guest. Pterosaurs, related to dinosaurs, as both belong to the same clade, Archosaurus. I think I need a refresher on the terminology and how they fit together in the evolutionary tree, but a clade is defined as a group of organisms believed to have evolved from a common ancestor, as measured by the characteristics of those organisms. Archosaurs include dinosaurs, pterosaurs, crocodilians, and other Mesozoic groups. And I'll circle back to geological time periods in just a moment. The third is da birds, evolving from small theropods with feathers approximately 150 million years ago. Finally, the fourth and most recent is mammals. Bats are the only mammal to evolve true flight. There is fossil evidence for gliders back to 160 million years ago, as far as mammals are concerned, but the oldest fossil of a bat, a true flyer, we have is about 52.5 million years old. And pterosaurs are not like bats and birds. Their wings were supported by a single elongated fourth finger. You could say they were always giving everyone the finger. Don't worry, I know my Pterosaur comedy is terrible, and this joke did not take off. So, quick orientation in geological time for today's discussion. We divide the age of the Earth into categories based on changes in the ecology and the processes found in the rock. Most large changes we see to make these dividing lines are due to large events, which also tend to cause extinctions. Our current eon, the Cenozoic, is the time of mammals, beginning 66 million years ago, after the large impactor caused a mass extinction that brought down the dinosaurs, all the way up to the present, 66 million years. The eon called the Mesozoic, starting back at that impactor 66 million years ago, back to 251.9 million years at the Permian and Triassic extinction event. The Mesozoic covers the rise and fall of dinosaurs, and many others, like pterosaurs. Because you see, before birds were cool, there were pterosaurs. They first came on the evolutionary scene at approximately the same time as the first mammals, in the late Triassic over 220 million years ago, and were part of the skies until the end of the Cretaceous 66 million years ago, when that large extinction event, also known as the KPG event, occurred, wiping out all non-avian dinosaurs. Today we're going to get into them, specifically pterosaurs, and a member of this group that was recently found and described, Haliskia peterseni. And I'm probably pronouncing that wrong, but don't worry, the guest will correct me. And I am absolutely ecstatic to dive in and learn more about prehistoric life and research in paleontology. And I'm so glad the lead author for the study, Haliskia peterseni, a new Anaguarian pterosaur from the late early Cretaceous of Australia, published in Nature's Scientific Reports. Okay, so welcome. My guest today is a STEM communicator being involved with bringing scientific results to museum exhibits, has consulted on scientific accuracy on dinosaur stamps, a children's book, and much, much more. Please welcome PhD candidate Adele Pentland. Hopefully I'm pronouncing that right. A recent graduate from Curtin, right. Or about to graduate from Curtin University.
Yeah, thank you so much for that wonderful introduction.
So, kind of in the back and forth as we led up to this interview, you told me the PhD thesis was submitted. Now, obviously, I had different ideas of what that meant. I thought you had finished your defense, but I mean, the writing part is usually the least fun part of the degree because it's like all consuming. How did you manage to cope to get through it?
So I kind of like broke it down into stages. So yeah, writing a thesis, which I think, and this varies from institution to institution, but I think it's generally accepted that a thesis is between 75,000 to 100,000 words. But I've been really fortunate in that I did my PhD part-time while I spent most of the time living on a 32,500 acre sheep and cattle station. But I also, throughout that process, was really conscious that I wanted to share these results basically as soon as I could. And to do that effectively meant publishing papers like along the way. So yeah, sort of in an unusual situation of having 7 lead author papers out. And it just meant that I had like a different set of problems when putting the thesis together in terms of like jumping through different hoops and making sure that I wasn't infringing on the copyright of the publishers who, in a weird way, kind of like own the work now, or they're distributing the work, and also, yeah, just trying to work out which version of a manuscript I could use in instances where the paper hadn't been published in open access. So yeah, it wasn't a whole heap of writing, although one of the requirements for mine was putting together a comprehensive list of all of the references throughout the entire document, which was about like 600 different references, and I think maybe 30 or 40 pages. That was a massive pain in the butt.
Yeah, reference lists are my least favorite part of any paper, putting it together. So I guess just going from my own experience, there's like generally, I mean, there's more than this, but there's 2 general types of theses. There's the story thesis, and there's the paper thesis. And I guess yours falls under the second one, where you have individual chapters or literally submitted papers instead of each chapter kind of leading to an overall story.
Yeah, correct. I would love to have had that sort of wonderful, like, overarching thing that just kind of, like, fed one into the next. But the fact of the matter is, the project kind of got started because fossils were being found at different locations. And then, in terms of, like, a null hypothesis, it's, is this new fossil that's been discovered, is it a new species? If not, what is it? If it is new, okay, amazing, but what is it related to? And just kind of going from there. So my thesis was called Early to Mid Cretaceous Pterosaurs from Eastern Australia. So focusing on fossils that were found in Queensland as well as Victoria. I had hoped to work on some of the opalized fossils from Lightning Ridge in New South Wales, but I just sort of ran out of time towards the end. But yeah, basically just trying to work out, okay, what is happening as Australia is part of this massive supercontinent called Gondwana, but I'm working on a group that have these wingspans of, several meters. Most of the pterosaurs I worked on had like 4 or 4.6 meter wingspans, which is equivalent to 13 feet or 15 feet. So they're massive animals. They can fly across the oceans easily, but is that what the fossils are telling us? So just trying to piece that together and I suppose reverse engineer it and work out what kind of a narrative can I string together with all of these things to make it make sense.
That must have been quite difficult. Although your thesis title seemed pretty straightforward in the end of it, all as some others like my own.
Yeah, I just kind of, for some PhDs, their project title and the scope of their project can change as they get through it, depending on, different challenges and stumbling blocks. But I was sort of fortunate in that was the idea for the project. And then I was able to execute and work with different partners, whether they be regional natural history museums, whether they be folks who are instrument scientists at the Australian synchrotron to basically shoot lasers and generate high-powered X-rays of the fossils that I was studying. At one point, we did take a couple fossils to a hospital to get them CT scanned, just with medical CT. And yeah, international collaborators as well. So yeah, really fortunate in that what I set out to do, which was describe some new fossils, that was able to sort of come together.
And I think I got you here to talk about one fossil in particular. And I also know that you've done all kinds of scientific consulting to STEM pen pals, even. And I want to get into all of that, but I think maybe the technical topic needs to be teed up first. Pterosaurs. You've already mentioned them. But for the listeners who may not be coming from paleontology, what were they and how did they fit into their brethren, the dinosaurs that everyone remembers?
Yeah, so a lot of people probably have a sense of what a pterosaur is, or they might be scratching their head and wondering, oh, why is she saying pterosaur and not pterodactyl? And they might also have the misconception that these are flying dinosaurs, but they're not. So, pterosaurs, they did live at the same time as the dinosaurs, and they are an extinct group that were wiped out about 66 million years ago at the end of the Cretaceous period, when a meteorite smacked into what is now the Gulf of Mexico. The Earth had a really bad day. So pterosaurs have been around since about 220 million years ago. They first pop off in the Triassic period, and even those earliest fossils, they're very distinct. They're very weird. So we are still trying to understand what their early origins look like. Mark Whitten has done some like beautiful speculative drawings of sort of these like gliding reptiles. But essentially, they're a really weird group. That's why I love them so much. Pterosaurs also include the largest animals to ever take to the skies. Quetzalcoatlus northropi was a beast that, when walking around, stood as tall as a giraffe and had a wingspan about the size of a small plane. Like, it's absolutely bonkers. It probably had like a 10-meter wingspan. So, to me, like, one of the massive joys about studying this group is that it really highlights how different and bizarre past life has been. And, you know, when you find the fossil of something that was as big as Quetzalcoatlus, and you understand that it did fly, it just kind of busts open any preconceived notions that you have about what is physically possible. But yeah, as I kind of touched on before, pterosaurs are distinct from dinosaurs. Most people agree that they're closely related to dinosaurs, and together they form a clade called Ornithodira. But they've got a couple key differences that distinguish them from dinosaurs, and that's in the shape of their shoulder girdle, their forelimbs, which are modified wings, and also their pelvis. But all that to say, basically, the biggest thing is that pterosaurs have basically modified their arms into being wings. So they have a humerus, they have an upper arm bone, they have a radius and ulna, which are the two bones in the forearm that we have. But then most of their wing is actually made up of their ring finger, which is stretched out and super long, and that supports a membrane of skin. So, like, in some ways, their wing is sort of similar to a bat, but it's September as we record. No, oh my gosh, it's now October. Or it's October for me.
It's still September for me. Yeah, it's still September for me.
It's spooky season. It's spooky season. So if you go out to the shops and you have a look at, like, plastic Halloween decorations, you can kind of see in a bat wing, they've got the 5 bones of the hand that are spread throughout that wing. Whereas a pterosaur toy shouldn't have that. Most do. But it should just be like bones that form the leading edge and just a membrane of skin that then attaches to the ankle. So really different wing structure to bats, and yeah, super different to birds as well. Yeah, that's the main thing that sort of makes them different. Even like the gliding dinosaurs, like Ichi, I think, its wing structure is really different to a pterosaur wing.
How common were these animals then? Like, did they fill lots of the ecological niches that birds do today, from predator all the way to like scavengers and grazers and the whole nine yards?
Oh, that's a really juicy question, and it's really difficult to work that out because, like birds, pterosaurs had hollow bones. So most pterosaurs, like that, the outer wall of the bone is only 1 millimeter thick, and then it's mostly hollow with these thin connective struts on the inside. They're designed, they've evolved. They've evolved to be as light as possible so that they can get up into the air. But because of that, those bones can easily get broken before they get fossilized. And even as fossils, once they're exposed to the surface, if the hollow bits aren't just completely filled with rock on the inside, then they get smashed up really easily. So in general, it's really hard to work out how common or abundant a group is just based on the fossils that you have. You can't really do like a one for one, because if we think of what are the most common animals in our environment today, they're insects, and they're very, very small insects. And yet there's only, a handful of deposits, like lake deposits, where you might have a bias towards a lot of the larval stage, but you won't be seeing like lots of the very, very small vinegar flies, we call them, and things like that. So yeah, and it gets super complicated as you do stuff with pterosaurs. But to answer your question, pterosaurs did have a range of diets. So some ate insects. It's been suggested that quite a lot ate fish. Some have been suggested as being scavengers. There's a few that are regarded as eating fruit. I'm not as familiar with seeds, but I'm also just, because I'm not a paleobotanist, I'm also just trying to scratch my head and think, like how common were seeds at this point? Because even during the Cretaceous period, during the Cretaceous period, flowering plants or angiosperms are just sort of like getting started. Whereas today, angiosperms are, I think it's over 90% of land plants. A lot of our most important crops are types of angiosperms. But back in the Cretaceous period, you have sort of more like conifers and ginkgos and cycads. They don't have like fruit, like the botanical definition of fruit, but they can have like seeding bodies and stuff. But then in terms of the nutrition of them, I'm not sure. But yeah, it's also interesting as well because for part of their evolutionary history, birds and pterosaurs coexisted. So even though pterosaurs evolved flight like 65 million years before birds did, there's been quite a lot of research that has been trying to examine whether the reason why, pterosaurs went extinct, is it because they were outcompeted by birds and things like that, which again is like a whole other kettle of fish.
Right. Huh. So I guess just to sum that up is there's a lot we don't know because we don't have a lot of information from the rock record being preserved, but it seems like they did at least have different ways of feeding and providing itself to essentially could be different ecological niches, but we need more information to fine-tune that or something.
Yeah, so direct evidence is super rare. That goes across the board with fossils. I should also shout out that there are some really weird pterosaurs that were filter feeders. They had like almost like a baleen, but it was made out of like hundreds of thousands of needle-thin teeth. It's called pterodostro. It's known from multiple individuals. They found like an embryo in an egg of this. They basically know what every single bone in Pterodostro's body looks like from multiple specimens. And yeah, they think they were filter feeders. Wow. They have gastroliths as well. So Pterodostro was actually swallowing stones intentionally to try and grind up some of the like really tough material that it was eating. So things like things with hard shells, so crustaceans and things like that. And for that reason, some paleo artists love showing pterodastros being pink, like a flamingo, which I'm super into.
Okay, well, we're here to talk about one special pterosaur, and it's not one of the special ones you've already mentioned, I don't think, anyway. Who is it, and how was it found?
Yeah, so I'm definitely not biased. I definitely don't play favorites. But yeah, last year I named a second species of pterosaur. It's the most complete in Australia. I definitely, as a Simpsons fan, have not created the like Homer like pushing the lamb away meme and included it with like my pterosaur boys' names. So Haliskia peterseni is a 22% complete skeleton that was found in November 2021. It's hard to believe that it's already been a few years since it was first discovered. But
And
someone
being the
reached out.
most complete at only 22%, hey?
Yeah. So it's really rare that you find like a complete pterosaur. Like even the slab specimens from the Jehel biota in China, where you can see basically the entire animal. Often you can't actually see like every single tail vertebrae down to the end, and normally you can't see the gastralia or which are the floating ribs. So yeah, even in those instances where something's complete, normally those bones don't fossilize because they're either very small or they're just not very well ossified in the skeleton. So what I mean by that is that there might be cartilage. But yeah, it's like just a constant work in progress. Honestly, before I worked on Haliskia, there was only one other pterosaur specimen in Australia known from a partial skeleton, which is again another one that I named in 2019. So yeah, there's lots of room for improvement. And when I visit schools and stuff in like various capacities, wearing different hats, I love saying to them, like, we have 5 pterosaurs in Australia. I've named 2 of them within, the last however many years. Just imagine how many are out there, and maybe one of you will find like the next best complete pterosaur. But yeah, for the moment, we have Haliskia. It was, found by a gent called Kevin Peterson. At the time, he was the curator at Kronosaurus Corner, which is a regional natural history museum in outback Queensland. And yeah, part of his job was going out to a publicly accessible dig site and seeing what he could find. And then at this actual other site, some of the guys from the council contacted him, having made this discovery. And even from those first photos that he sent to me on Instagram, I could see there was a complete lower jaw in the ground, which we just never had in Australia. And then when the specimen was recovered and taken back to the lab, and he was doing more preparation work, there using fine tools to remove the rock that was covering more of the bones, he said to me one day, there's like a bone that looks like a thin piece of spaghetti. And I was like, I know exactly what that is. It was a really thin, delicate bone in the throat called the cerebробranchial. And just knowing that you have such fine, delicate bones, which often don't fossilize, was just, super special. And I knew we had something good on our hands.
Awesome. There's nothing like the discovery of something new, especially in science. It's kind of what we do in science. Let's jump into the actual paper that came with this and where you introduce this to the rest of the world outside of the small circle that found it. And I'm going to totally embarrass myself here. So I did the rock side of things. I stayed away from chemistry and biology because I didn't know how to spell. Yeah, that was the reason for taking geophysics. So I also don't understand species classification in evolutionary groups very much. So I'm going to attempt to pronounce these, and after that, I would love a retelling or an explanation of how or what the factors and characteristics that were used to determine the zoological taxonomy classification. Even that's a mouthful. So, kingdom, Animalia. So that's like animals. I got that one. Phyla, chordata.
Class Reptile, Order Petrosauria, Suborder Petrodactylia, Family Anagrida, Subfamily Anagrina, and then the genus, which is the species name, Haliskia peterseni. I butchered it, I'm sorry.
That's all good. So let's just take a shortcut. So we already know this this animal has bones, or like we already know it has bones. So that rules out plants. They don't have bones, and it rules out like fungi and bacteria. So yeah, phylum Chordata, it's something that has a backbone essentially. So with the specimen, we had some vertebrae. And the vertebrae, one of the main jobs of the vertebrae is, I suppose, to like give the body like some structure and stuff. But also that neural canal, that hole through the vertebrae, that protects the spinal cord. Because if you take a knock to your spinal cord, then your nervous system is basically not going to be able to do its job very well. And then, yeah, this is technically a special type of reptile. So as like a bit of a shortcut, if you know that the rocks are Cretaceous in age, the Mesozoic period and the Mesozoic can then be broken down into Triassic, Jurassic, little obscure thing, you might have heard of it, and Cretaceous. So age of reptiles, it doesn't, well, at this time there are mammals around. They're very small. Based on size alone, you can probably rule out that it's probably not a mammal. And yeah, it has these super elongate wing bones. So it's a type of pterosaur. So that is where the order Pterosauria comes in. And then pterosaurs can be split into two major groups. You have pterodactyloids and you have non-pterodactyloids. So pterodactyloids are sometimes called short-tailed pterosaurs. And if you have something from the Cretaceous period, chances are it's probably a pterodactyloid. So again, just kind of process of elimination, Occam's razor, the most likely thing is probably what it's going to be. And then we've got our family Anhangueridae. That's how I pronounce it. It is based on, like, the first Anhanguera was named from Brazil. And when I went to Brazil, I'm pretty sure I pronounced that word around some colleagues and they didn't correct me. Unlike the family name that has an X in it, which in Portuguese, in Brazilian Portuguese, is pronounced like a sh. So the word for cup in Brazilian Portuguese is xícara, not Isikara, if I was pronouncing it with my really broken Australian Queensland accent. But yeah, so my supervisor and I were saying the word Tupuxuara, but it should be pronounced Tupushuara. So yeah, trying to pay attention to like who named it and how they pronounce things is super helpful. But Anhanguera basically means old devil, which is a sick name. And a lot of members of the family Anhangueridae have what's called a crest on the end of their snout. So I've tried to like explain what this is before in only audio formats, and it's always a little bit tricky. But it's kind of, imagine like a spoonbill, but turn that on 90 degrees. It's kind of like this weird sort of diamond profile at the end of the snout. And if it's flying at you straight on, it's very, very thin. It's only 1 or 2 millimeters thick. So we had enough of the skull of this new pterosaur from Queensland to say, oh, it has a premaxillary crest. It's probably a member of this family, Anhangueridae. Other people might be more familiar with the family name Ornithocheiridae, especially if you watched Walking with Dinosaurs, for example. Some people think that they're the same thing. Some people maintain that they're different. Let's not get into it. If anyone really wants to know, they can message me about it. But I think that's like enough taxonomy. And I realize like it's super complicated, but as people who work in science, generally speaking, it does help to group things together by like similar uniting features, depending on like you might be working on rocks and just classifying different like igneous rocks. You might be looking at microbes under a microscope and having features that you use to classify things is something that you see across the board. I just think that sometimes paleontologists, I wouldn't say take it too far, but anyway.
You're basically describing lumpers and splitters right there.
Yes. Oh my gosh. Yes. So if you've never heard that term before,
really common thing in geology.
A splitter is like, a splitter kind of has the mindset of like, oh, this is new and nothing like this has ever been seen before. Whereas a lump, like it's two extremes, right? But a lumper might just be like, oh, like everything that looks like this is all this one species, for example, in paleontology. There are pros and cons to both approaches because, of course, like even if you just look around, if you're in a room of people right now and you look around, you will see individual variation. And that's, reflected through like different genetics, like different life stages, differences between sexes, like all of these things as well, which can be really difficult to parse out when all you have are bones. And not all of the bones either.
Yeah. Now my next question is kind of following along the same tract and perhaps maybe should have come first, but I kept coming across because I actually read the papers that I do this. Sometimes I don't understand them. I felt pretty confident in some of the non-super technical stuff about the bones, but one thing that kept coming up was a way to refer to specific fossil specimens in the paper, I guess, with letters and numbers, almost like a code. I'm not quite sure I know how to crack it, but if I were to take a guess, each species discovered is assigned a standard to represent that species, like a standard for dog breeds at a show. And this number, it gets to be assigned as that species standard. Is that what it is, or am I stretching it too much?
No, like you're very, very close. Okay, so let's use the example of Haliskia, and the specimen number is KKF1426. So that is a museum catalog number. So the idea is that you might have, there are different institutions, say, for example, another one that I know off the top of my head is AAOD, which is Australian Age of Dinosaurs. So when you see that at the start of a number, you know which museum, you know, hopefully, what the geographic location of that specimen is, if you then want to do a research visit to see it. Museums have to be audited as well. They need to prove for, I think, insurance purposes and to the government as well, that they have the specimens that they say they have. And ideally, with museum catalog numbers, each number is unique. There are no double ups as well. So, and how this kind of works in terms of my research is that, say, for example, someone later this year, and I don't think this is going to happen, hopefully not, say in our example, someone says Haliskia isn't a valid species. The characters that you've used to identify it and distinguish it from other members of its family, you know, if they find a specimen and it's like, oh, actually, you know, these three features are also found in 4 other species, then Haliskia isn't a valid species anymore. But KKF1426 still exists. It will always exist. So if the species name is sort of like the wine label, then the museum number is kind of like the bottle, like the physical thing that exists. And in that instance, someone might say, okay, KKF1426, so that's the holotype specimen of Haliskia. That's kind of how that is working right now. But if we circle back to our example, and someone tries to nuke Haliskia and tell me that my work is garbage, which does happen in science, and like science is self-correcting, in that example, they might say Haliskia is a junior synonym of like another species, and KKF1426 should be a referred specimen of like a species that was named, maybe 5 or 10 years ago, something like that. So yeah, it also does get tricky when, and it doesn't often happen, but specimens can get moved to different museums, and then those numbers can change. But it doesn't happen that often, so it's sometimes if a fossil has a bit of like a complicated or a contentious history, for me sometimes in my like library of papers, it's a lot easier sometimes to just put in the specimen number and work out who said what about it, rather than trying to follow what different names it's been given. And also some people will come up with nicknames. Say, for example, they might call something the Richmond polycotylid or polycotylid, however you want to pronounce it. That might only be used in one paper. So then to sort of like track it it's super messy. But essentially, museum collection managers are probably thinking that I've made a hash of this. But those unique numbers should mean that in a well-organized collection, if someone says, I would like to study this specimen, you know exactly where it is on the shelf, and then you can get it ready for them to have a look at so they can do their science. I hope that makes sense.
So one of the things that you said right there was holo species, like the one...
Yeah, holotype.
The specimen that is the best Right. So
it's
I guess where I was coming from, my understanding was that part, like you could end up changing the fossil number, like a newer fossil that's more complete can become the holo type, right?
No. Normally if there's like a new holotype, which is called a neotype, normally what's happened is the original fossil got destroyed. Say, for example, during World War II, when those fossils were bombed, then they needed to define a neotype, a new holotype. Even if you have a holotype and it's,
We're back to
10%
Spinosaurus,
complete.
by the way, for those that are following.
Yeah. Take a shot. No. I mean, yeah, I haven't talked about Jurassic Park yet, but all roads tend to lead back to Jurassic Park and Spinosaurus in some ways. So, yeah. Oh gosh, what was I saying? Just distracted now. If you have a holotype that's 10% complete, and then if you have a 100% complete specimen that's found later, normally what happens is the holotype still remains the holotype by definition. It just kind of might get pushed to the side in the literature, and people will focus on that really nice, more complete, more anatomically informative, like full of bones specimen.
Interesting. So that is different from other fields of geology. Like, for instance, if you found a better set of strata that better shows, let's say, the KT boundary where everything got nuked due to the asteroid, you would actually change the best, like, what the standard is for the KT boundary. You would actually change it.
That makes a lot more sense.
To the new spot. So I'm surprised it doesn't change to the individual fossils.
Yeah, I if I had to guess, I'd say that paleontology has like a few hangovers of this is the way it's always been, like that kind of mentality. So things might change in the future. It would be handier if it was, just the holotype is the best representation of X, whatever it is. But sadly, that's not the rules that we operate by.
I learned so much from this. I'm so glad I keep doing this. The next section of the paper I want to get into seems to hit at a common problem, piecing together individuals and species. We've already alluded to it here, that you could end up renaming a species based on other data. And I guess my context comes from the last time the podcast looked at tyrannosaurs, where in my research, separate species just kind of disappeared from the literature because they were lumped in with other species. In tyrannosaurs, they're a bit more complicated because they grow so much. And so the smaller ones were being labeled as their own species, even though they were just not adults. But with not a whole lot of bones and lack of preservation, I assume there's similar issues here, right?
Yeah, so there definitely can be. with the groups that I study, it's more a case of whether the variation, like the differences in the bones, are because of maybe like male-female variation. And I think it might also just come from looking at pterosaurs through a bird lens and knowing that in some bird species, they don't tend to have big differences in the body size, but their ornamentation, like their feathers, their coloration, can be wildly different. Think of a peacock and a peahen, for example. That's one of the extremes. So in Anghanguerian pterosaurs, there has been some debate about whether species that lack a crest entirely are distinct. That's kind of the assumption that we have. But in terms of like how big the crest is, early days, there was a lot of emphasis put on like the angle, the shape, like how big it is. Does it reach like the end of the snout? These days, not so much. But I will also add the caveat that when we do what's called a phylogenetic analysis, we are still sort of placing emphasis on those features. But to sort of try and like tie this in a bow, it's important to note that some of the Anghanguerian pterosaurs with the biggest wingspans, they don't always have the biggest crests. So there's, been like a little bit of that going on. Unfortunately, for better or for worse, this is a group where we don't have basically any juvenile or like very few subadult specimens. So, which is crazy because there have been so many fossils found from Brazil. The Araripe Basin is a fossil Lagerstätten, which is just a fancy German word to say that they have a crazy amount of fossils that come out of there. And there is quite a lot about fossils that have been illegally smuggled out of Brazil. But out of all of the specimens that are known in museum collections and even the ones that are in private collections, as far as I know in the conversations I've had with colleagues, we still don't have evidence of these young animals. So to me, that might signal that the colonies, the rookeries, like where the juveniles are hanging out, are, in a different space to where these adults are hunting in these lagoon and, in my case, the Eromanga Sea, these inland oceans. They're not able to get out there and hunt for those reasons. So they're not being fossilized with the adults. So it can, definitely be an issue as well. And that's something that I need to keep in mind. It's something that I hope that I always sort of have in the back of my mind when I'm looking at a fossil, trying to be aware of my own ego as well, because I would hate and be super embarrassed by the fact that if I named a new species and then someone else later said, oh, actually, it's the same as another species you've already named before. So when I was working on Haliskia, even though I knew it was 6 million years older than Ferro-Draco, it was in a different fossil environment, I really had to try and keep myself honest and say, okay, some species do last for millions of years. Really prove to yourself and back yourself and know, or have a long list of these are the reasons why it's a new species, not just the underlying assumption that, oh, it's 6 million years older, of course it's going to be a new species. No, you need to look at the bones. If you have, the same species here on Earth and on the moon, it doesn't matter the separation of time or distance. Again, you just need to really focus on it and, just having great collaborators that keep me honest as well, that I can have these conversations with, also helps make the science really rigorous.
Next, we get to where I was going to bring up the Spinosaurus controversy in a different way. Because I guess just like the T-Rex's, size is something of a focus, especially when it comes to the prehistoric stuff, because it does matter, at least for journalism. It seemed to me, and I'm a complete outsider, that the paper hinted at wingspan estimates have been contentious with different species. Is that right?
Yeah, so of the 5 species of pterosaur we have in Australia, Two are known from partial skeletons that preserve parts of their wings, but not every single bone in their wing is represented. And then the other three, they're just known from skulls. So I have a little bit of issue with people trying to estimate a wingspan just based on a skull, because even if you know what family it belongs to, depending on what you compare it with, you might end up with something that's, 3 meters, or it could get blown up to like 8 or 9 meters. I don't have the exact conversions in feet, but I think that'd be, as big a difference as like 10 feet to 20 feet. Like, that's a huge difference, right? So, yeah, I just think it's bonkers as well. Like, if I knew someone's hat size, I wouldn't know what their shoe size was. Because there is that level of variation, and yeah, for me, I just try and be conservative. Say, for example, with one of the first pterosaur species that was named, we only have the middle section of the skull. It could be, its wingspan's probably somewhere between 4 to 6 meters. We don't know at this stage. Hopefully we find a more complete specimen and we can fine-tune that. But yeah, I'm pretty skeptical and very aware that, yes, the biggest, the smallest, the fastest, there's a lot of emphasis that's put on those things and those hard numbers as well.
And don't worry, I work in meters too. It's only my American listeners that are still in feet. I guess the British are too, aren't they?
No, I think the British are
Sorry.
going with meters and stuff. Yeah, no, it's all good. I am just I am in the loose habit of trying to do the conversions and stuff because with my podcast, even though I'm based in Australia, I think most of my listenership was based in the US, which was wild to me when I first started. But yeah, love having that in there for accessibility. Maybe one day you will see that meters is truly superior, but if you work in feet, I know you're not going to Google it, so I might as well slap it together in my notes.
Yeah, although anyone listening, you can get pretty close to 3 feet per meter. As long as you're not having a ton of meters, it's going to work out just fine. Yard and meter is pretty close. But at any rate, we kind of did a little bit of how they lived, because you kind of went over the fact that we don't have young ones in the fossil record. So it is completely conjecture, I guess. The young ones, seaside cliffs, trees, we have no hard evidence then?
Yeah, so there's a few sites where they have eggs and nest sites. So I think again, it's like kind of difficult to know because if you have like a storm deposit and you have a bunch of eggs that have been washed in, you can't assume that they were all laid by the same individual. And you can't really assume like what the clutch size was. But it seems that for the pterosaurs that we know, they have multiple eggs rather than just one egg. But if we think about birds as well, like there's a huge amount of like strategy and diversity. Like some of the really large species, they'll have maybe 1 or 2 eggs. One is sort of an insurance policy for the other egg. But when that hatches, the parents put all of their effort and time into trying to raise that one chick. Think of, say, emperor penguins, for example. They have a really challenging environment. Food sources are limited, so having a clutch size of 8 or so chicks, they're probably not all none of them will probably survive in that instance. So there's that. But for the eggs that have been found of pterosaurs, I'm so glad I get to talk about this because I was going to include it in my thesis and then I ended up cutting it because it wasn't relevant. But it seems that the eggshells for a lot of pterosaur eggs are not super hard-shelled. So they're a little bit different to birds. So there's been a little bit of conjecture about incubating those eggs in warm sand, for example. And sort of that strategy, for example. But yeah, if pterosaurs are in trees as well, then having your eggs off the ground away from quite a lot of predators would also be a great strategy. So there's a little bit of conjecture about the chemical composition of the eggshells. Technically, my boss's boss is a geochemist. I have not really like picked up anything like that and haven't really gone down that line of analysis in my own research, but that seems to be what we have at the moment. But I think there's only 3 or so species where we have eggs and embryos and eggs represented out of the 200 plus pterosaur species that we know of. So again, there's probably like a wide range of behaviors and habits going on. And yeah, in terms of, parental care strategies and stuff, this is something that I did touch on in my thesis, sort of building on work that was done by Darren Naish along with Liz Martin Silverstone and colleagues. They talk about the fact that based on the wing bone ratios of some of the pterosaurs they looked at, it seems that soon after hatching, pterosaurs could fly, which seems to suggest that there's not a lot of parental care going on, that the young aren't dependent on the adults, and they can relatively quickly get on with things and get their own food and things like that. But again, there's, with those really big, like giraffe-sized pterosaurs and stuff, well, are they doing the same thing? We don't have fossils to say whether that's the case. All sorts of things to think about. The amazing thing about science, and definitely with paleontology, is the more you find out, just the more questions that you have.
Yeah, because if that isn't happening, you're doing it wrong.
Yeah. The idea is to try and keep yourself in a job.
Hey, now. I think it's always a bit more about like just exploring the universe, and life would be so boring if you just had all the answers. I mean, that's the human condition, I think.
Yeah, and paleontology
is there anything
for me
else
is
we've
like
missed from
time travel.
Yeah, for sure. And before we move on to more of the present, is there anything we missed from the paper or in our discussion of the individual? I won't try to pronounce its name again.
So with Haliskia peterseni, I mentioned before it had like those throat bones, like that thin piece of spaghetti. Of any pterosaur where we have like the complete lower jaw and the throat bones, Haliskia has like the biggest ratio. Like those throat bones are super long compared to the lower jaw. So when I commissioned Gabriel Uguero to do the paleo art for that, which was amazing, the best like money I've ever spent, we were sort of discussing like, maybe like we'll give it a bit of a gular pouch, which is speculative. We don't have any soft tissue evidence with that fossil. But yeah, it seems like it's got like a really strong tongue to maybe, I don't know, slurp down fish or cephalopods, whatever it was hunting. So yeah, there's some of that going on. But then in terms of like the specific diet for this animal, quite a few pterosaurs and other creatures that lived in the Eromanga Basin in this massive inland sea that covered part of Australia during the Cretaceous period. Quite a lot of them have these lines or ridges on their teeth that go up and down from like the tip to the base. But Haliskia doesn't seem to have any of that. And I don't think that any of those ridges were present and they've eroded away. I think they're just genuinely not there. They're absent. So when I compare that with, say, like the teeth of Mathanga, which has these really chunky ridges, to me it's like, okay, well, the idea with the chunky ridges is kind of like it helps to grip food. So if you think of your fingertips when you're in water and you get like pruny fingers, the idea, or not the idea, what is happening is your body is doing that so that you can grip things better. Like those extra surfaces help you grab things better. The same with ridges on teeth. So the fact that Haliskia doesn't have them there, yeah, just it's not important, or there's something else going on. There's more work that I'd love to do on it, but I have like a few other projects and stuff that are sort of like begging for my attention, including like museum and exhibition design to try and like showcase that specimen as best I can. But yeah, there's If you want to read more about it, I wrote an article for something called The Conversation about what that fossil can tell us. So if reading scientific papers isn't so much your thing, that's also like a really great place to start.
Yeah, send me the link. I'll make sure it gets included in the show notes. But you were just mentioning the same as the next question I was going to bring up, because introducing you, you spent a fair bit time helping design, exhibits anyway, producing them in some way for museums. And I guess you're just telling me the plans that you are going to make the same treatment for this species or this discovery, or has it already happened?
Oh, so it hasn't we're in the messy middle. We're in the interesting part. So in terms of some of the other exhibition designs that I've been involved with, I can't take a whole heap of credit. So one was with the Australian Age of Dinosaurs Museum of Natural History, and that was for the first species that I named in 2019. They have what's called their holotype room. So all of the fossil specimens that are new to science and they define their species, they normally keep in one spot, which is fine. But most of the things that are in that room, and you sort of look at it, you're sort of on a stage and you're looking down at these specimens, a lot of those bones are from these massive long-necked dinosaurs, these sauropods. Think of Littlefoot from Land Before Time. We're working on a different scale. Like, my boy is not as big as those other sauropods. So in terms of my input for that exhibition design, I basically said, I know we call it the holotype room, and I know this is a holotype, but can we please not have Ferrodraco there? Can we have it in this specific museum display case so that people can see it? Because I worked as a tour guide at that museum for a while, and I was already aware that for people who have low vision, having, the biggest bone in Ferrodraco's body is about 30 centimeters as preserved. Having that be sort of, 4 or 5 meters away for someone with low vision in a room that has sort of this like nice but sort of atmospheric and moody lighting would have led to a lot of frustration, which is not what I wanted. So yeah, for that smaller specimen, just trying to have it where people can get up close and personal and see it as well was one thing. And then, yeah, I was lucky to get asked by Museums Victoria or Melbourne Museum to just supply them with some information on the pterosaurs that I described from here in Victoria, which are the geologically oldest pterosaurs from Australia, as part of their Victoria the T-Rex exhibit. So in terms of like the graphics and that, I didn't really help with that side of things. I gave them the information. And then, yeah, it was a delight to sort of see that brought to life, and a joy to know that for the brief window of time that it was on display, it got seen by somewhere between 200,000 to 250,000 people, if they turned around and weren't too distracted by the T-Rex that was behind them. But yeah, otherwise, Ferrodraco is, for anyone who does a tour of the lab at Age of Dinosaurs, Ferrodraco is mentioned explicitly, and it's been seen by, since October 2019, like 270,000 people. That makes me so proud. Like, I've said this a bunch of times. If I get hit by a bus tomorrow, I know I did right. I partnered with a museum. A lot of museums, they have their holotypes sort of in a back room or in a storage area. Only maybe 3 or 4 people get to see them a year. Whereas the fossil that I got to work on, because they believed in me, they gave me a massive opportunity, it has made a real difference. Those museums, those regional communities, they really heavily rely on paleotourism. They rely on people going out and visiting the area. A lot of the time they're sort of like retired, but we also would just get so many kids who came specifically to the museum. They begged their parents because they loved dinosaurs and they wanted to see that stuff. Like, that is super special to me. That is the most important part of my work. I don't really care. Like, the naming things, it does help. Not having that understanding of the specimens, it does help. But seeing it translated into something that inspires like the next generation to be like, wow, I didn't think you could do paleontology in this country. That is something I'm super proud of.
Yeah, these museums are a big part of the local communities, and I only know of one in Canada, and that's obviously the Royal Tyrrell Museum, and it's a similar thing. It's a small little community, and their only real tourism is bringing into that amazing museum. So yeah, that type of work is crazy good. I also noticed, though, besides the fantastic work you're doing with the museums and trying to being like their scientific advisor for some of these fossils, you're also doing that for a children's book.
Yeah. Remind me as well, and I'll circle back to the current like stuff I'm doing with Haliskia. But yeah, so I've been working with a wonderful illustrator called Andrew Plant. He's done a number of children's books. And he wanted to make something that is all about Draco. So it was so funny when he first emailed me, because I think Haliskia had just been announced, and he was already like well into the process. I think he'd already sort of like pitched things with the publisher, which is CSIRO, and he was like, just my luck, as I'm, just about ready to get this, or, it's like 80% complete, you name another new species. Well, I hope you don't mind, but we'll make it about Draco. And I was like, yeah, absolutely. So I did, scientific advising with that, working with Andrew, who, anytime I've worked with a paleo artist, the questions that they bring just make me level up in terms of my understanding, because they honestly ask me questions that I just haven't thought of as a scientist. I found the same when I was working with Peter Trussler for the Australia Post stamp series. Some of those emails were like 4,000 words of just answering his questions, so it was super good. It also features some of the other Cretaceous fossils that are found in Queensland, but essentially Draco is the main character, and I'm absolutely thrilled with that. It's just something that I wouldn't have, if you told me like 5 years ago or 10 years ago, that, a fossil that I named would be featured in a picture book, I would have told you you're hepped up on goofballs. But yeah, so it's basically done, but it will be scheduled for release in early 2026. So you won't be able to snatch it up this Christmas, but if you follow me on socials, I will definitely be crowing about it. And yeah, just to circle back to the stuff with Haliskia. So when things like, so they had this new pterosaur, and they're like, all right, we need to move all our pterosaur specimens, because we've got to try and like keep them all together, but there's quite a lot that exceeds like these two display cabinets. So initially I just kind of modified one of the scientific figures for a display to try and show which bones were where on the specimen. But I'm working with a friend, Zev Landis, on basically trying to revamp that exhibition space. So we, through the Regional Arts and Development Fund, are potentially going to be going up to Queensland to have a look at the space and really try and figure out what can our budget handle. Can we incorporate some amazing 3D prints from some artists? Can we potentially sort of get some of that artwork that Gabriel Guedo already did and have it in the space? And how do we also like tie everything together and have a beautiful, like, cohesive story? And then how do we condense that down as well for younger visitors, to have not so much like just walls of text and information, but how do we have questions for them to engage with and get them really thinking about what is in front of them?
Yeah. There seems to be so much outreach stuff that you're involved with.
Yeah.
Just in STEM in general, including, you said already at the top that you have your own podcast. So maybe this is a good time to like call that out, and anything else that you really feel like needs to be really flagged right here.
Oh, okay. Well, if I don't tell you about the book that will be out before Christmas, like, my friend will probably tackle me into the ground.
Okay, well, I wasn't aware of it, so I didn't know to ask.
Yeah, no, that's fine. So it's only been announced, I think, in the last like week or two, but a really good friend of mine called Dr. Caesar Pushmarin, he is a wildlife veterinarian, and he asked me to be part of this amazing book called Nature People. So initially, when he was working on it, he wanted to call it Wardens. And, you know, it sort of features different Australian naturalists as protectors of the things that they work on. So for quite a few of them, say Steve Haslam, for example, who is the founder of Quoll Headquarters, he's trying to champion these like feisty little critters. There's someone who's an expert at insects. We have people working on bats as well. And then obviously I'm a little bit different because the things that I'm working to protect are dead. So, you know, they're already extinct, but to my mind, you know, fossils are a finite resource. They will never exist again. And looking after the fossils that we have and trying to learn what we can about them, especially for stuff from the Cretaceous, when you have like elevated atmospheric CO2, like increased temperatures across the board. It's just interesting to see how different animal groups respond to those conditions, especially when you've got a group, say like sharks, for example, when all of the families that we have today, they first popped up in the Cretaceous period. So you have all of that going on, but so I was interviewed for it for a while ago, but Caesar did such an amazing job. It's a beautiful book. He shot all of the photos on 35mm film, and it honestly has like some of my favorite photos of me in here. And I realize I sound like a psychopath and a narcissist to say that, but like I was wearing no makeup. I felt pretty burnt out when those photos were taken, to be honest. We just had Caesar on vet placement on our farm, and then we were going to start shearing for like 3 weeks. So basically for me, that's like 12 to 14 hour days nonstop for 3 weeks, plus having to cook for everyone. But yeah, like those photos are just so light and they're amazing. So that is available for pre-order now, and pre-orders, the book will come out on the 28th of November. So again, that's Nature People by Dr. Caesar Pushmarin, published by Affirm Press. So yeah, super excited for that. And then, yeah, as you said, I have a podcast called Pals in Paleo. I don't think I've released any new episodes this year because I've just been in the depths and the dungeon of thesis writing. But now that I'm sort of like in a groggy haze, like kind of clawing my way back into finding the new normal, hopefully there'll be some episodes. Or my laptop sadly died as I was writing my thesis as well. So like wading through the wreckage and trying to recover like files and stuff has been like, it's been in the too hard basket for a few different reasons. But I'm hoping that I can try and like salvage some audio that I recorded but didn't like cobble together into episodes at some point. Otherwise, yeah, I've been doing school visits, gave my first keynote presentation at a school this year, which was amazing. Spoken at some school assemblies, and yeah, part of this program called STEM Pals. So science, technology, engineering, mathematics, Pals. And it's just kind of like a sweet letter writing program. I always wanted a pen pal as a kid, but now I get to do that as an adult, and basically just show kids that there are a range of different careers you can have if you're interested in STEM, but also like scientists aren't, you know, just a jack in the box of like they do science, like they're in the lab and then, you know, the lid gets turned off and then they just power down. No, we're real people. We have interests. I'm still super into Pokemon. My little gift to myself has been trying to play for the first time Soul Silver, the Gen 2 remake on the Nintendo DS. So yeah, all kinds of different things.
That's amazing. You're able to keep all of most of that still kind of juggling and finish your thesis on top of it. But we've come to the dreaded question, the hardest question here on Whimsical Wavelengths, the one that I pose to every single guest that comes on. It's the traditional last question. What is your favorite science joke?
All right, let's keep it thematic. Why can't you hear a pterosaur go to the bathroom?
I don't know why.
Because the P is silent. Get it? Get it? It's spelled P-T-E-R. Oh, yep. It's not the P you were thinking of, was it?
Thank you so much for coming on, and I wish you all the best in the upcoming thesis defense.
No worries, thank you. I'm hoping it's gonna be a little bit of fun when I have to do it's called my Milestone 3 presentation, like the big presentation you have to give before you submit your thesis. One of my panel members prefaced his question by saying, I have to ask you a question. Like, I am mandated to ask you a question. And then he pointed to a pterosaur toy on his desk, and I just got to, like, let loose and pop off about Kaiwajara Dabrowski, which is great. So I'm hoping it has a similar energy to that.
Okay, well, that one went a little longer than I had hoped. So I'll keep the end bits nice and short. And quite frankly, at this very moment, I don't even know what's coming up next. I have a couple of irons in the fire for 2 different interviews. I also have a solo episode that I've been working on, all about the planets and the process of science. I've also gotten back somewhat recently from Saudi Arabia and the ensuing viral infection that came with the plane ride. No, it wasn't COVID, but it still knocked me out for a week. Joys. Anyway, I'll see you in 2 weeks. I hope you enjoyed this one, and by all means, subscribe, leave me a rating, and of course, send me questions or show ideas or whatever. Don't be afraid, tag me on social media. Cheers.
In a world so chaotic, so misbehaved, echoes of melodies remind us it's all waves. Colors weave stories painting the sky, swaying to rhythms as the galaxies fly by.